Hey, good morning, everybody. This is Mike Menny, one of the LaunchCode mentors. We're going to talk about version control in this mini lecture. It should only take about 10 minutes, so hang with me. It's a really important topic. It's going to give you guys some great productivity gains right now, and it's going to be pretty essential down the road once you start working on a team. So, to get started, let's go back to the beginning. Let's go back to real simple times and look at pset 1. And let's talk about Mario. Now, the thing I saw a lot of people doing with Mario is, if you know you're going to make a big change to Mario, like you're going to change this variable, and you're just going to mess this file up, where you know it's not going to compile anymore. Well, you don't want to do that because then you've messed up your original copy and there's no way you can get it back. So a lot of people say Mario.c, copy it to Mario1.c. And then they would say gedit Mario1.c, and they could do whatever they wanted and not have to worry about messing up their original copy. Now that's legitimate, but it's going to get tougher as we go down the road. For example, let's take a look at problem set 3. Alright, so as you know, problem set 3 uses a makefile, and it actually find.c will actually use helpers.c as a library methods. And so we're not really able to say copy helpers.c to helpers1.c because, and then make all of our changes to helpers1.c, because even if we did that, we'd still have to go in, we'd still have to change all the references in our makefile. We'd still have to change all of the references in our find.c file, helpers.h, and we'd have to change all the references in our generate.c file. So that's pretty unacceptable. That's something we're not going to be able to do. Granted, we could make a copy of this entire folder and call it find1, but we're going to do things a better way. We're going to do things the easy way. And so we're going to let the computer take care of all of our versioning completely for us, and it'll be very, very transparent. So if we go ahead, we'll clear the screen. We type in Git. Git's the version control system that we're going to use. It's becoming the becoming the de facto standard for the industry, so it's something to definitely get to know. If we say git init, that's going to create an empty repository for this entire directory of pset3. Now the next thing we do is we can say git status, and it's going to show us all the files that we're tracking using our version control system. Currently at the moment we're not tracking any of our files because we've got untracked files and we've got makefile find.c. These are all being untracked. So the way we track them is by saying git add makefile. Now if we say git status, we can see, okay, great. This makefile looks like it's now being tracked. It's in our version control system. So let's go ahead and add the rest of the files in. The star.c notation simply allows us to add any file ending in .c. Also note, so if we had compiled files in here, so just the helpers binary file, we would not add that into version control. We only add source code, and the reason is that the binary files change way too often to version them. So we're only going to add the source code. And we don't have any binary files in this case, but if we did, we'd leave them out. So, with that being said, let's do a git status again. Okay, great. We've got all these files in the version control. Let's go ahead and save them. So the way, just like you're pressing save in gedit, the way you save in Git is by saying git commit You're going to say M, and you're going to give it a little message. You're going to type in first commit. Fantastic. We just pressed save on the entire directory of files that we were working with. So now that we've got, now we're able to comfortably know that we've always got a state that we can go back to. We've always got this original state. Now let's start talking about how we can modify some of these individual files and do the same things that we were doing before. So essentially, we've got these files saved, but we want to make some pretty big changes to our code. We don't want to have to copy everything, so we're going to say git branch code experiment. And so we type in git branch. So essentially that created a copy of our entire directory. And so now we've got a copy that's called master, and we've got a copy called code experiment. And so if we want to switch over to our code experiment copy, we just have to say git checkout code experiment. And now we're on our code experiment copy. So what that allows us to do is now we can come in, we can make changes. We can make any changes we want and not have to worry about messing things up. I mean, we can do anything we want and not have to worry about messing things up. We're going to type a Git Status. Okay, we've got a couple of files that are not ready to be saved yet, so we're going to say git add helpers.c, which is the file that we just changed, and then we're going to save it. We're going to give it a message again. We're going to say code experiment commit. Great, so now we've just saved that code on our copy called code experiment. And you'll notice if we go back, we'll look at our branches again. We've got two branches. We've got code experiment. We're currently on code experiment. And we've got master. But if we go back to the master branch and just type checkout master, you'll notice something interesting. So now we say gedit helpers.c. Look, all the gobbledygook that we typed in here is not there because this is a different copy of the code. And so even though in the file system, it's still the same files there. If we go back a directory, it's still the same files there. There's no physical copy. It's just the computer's taking care of the versioning. Git is taking care of the versioning for us. And so now we can even make changes on our main copy, and those won't affect our experiment copy. For example, let's say helpers.c. And so since this is our main copy, we're not going to do anything that messes it up. We're just going to put in a real simple printf hello world. Very simple. Now we can say git status. Alright, we just changed helpers.c. So if we want to save helpers.c, we got to add it in. And then we've got to save all of our files. Okay. Alright, so we're on the master branch. We just saved some of our files. If we go back to our code experiment branch, we say gedit helpers. Let's see. Notice, hey, it said, hey guys, this is not the same file that you were looking at before. This is actually a different file. Why don't you go ahead and reload the file? And that's what we're going to do. And so we look down at the search function. We've got all of our gobbledygook, and we don't have that hello world statement that we just put in. It's because it's saved on our previous copy. So that's the basis of what you guys can use Git right now. So you don't have to be making all those superfluous copies and making helpers.1, 2, 3, 5, 10, 30.c. But there's a lot further that you can go on this type of stuff. And fortunately, there's some awesome resources out on the internet to help you. For example, this is a great site. It really helps you understand the versioning and the branching in Git. So as you can see, C0 is the first commit to this repository, and we're currently on the C1, which is the second commit. We're on the master branch. So if we say git branch code experiment, well, just call it experiment then. Okay, so now we've created a copy of that code. We can say git checkout experiment. Now we're working in that copy of the code. And say git commit. Now we've added a piece, we've added changes to that copy of the code, but not to the master part of the code. So if we go back to the master, we can add changes here. And you'll notice that they are completely separate. We've got two different lines of code. They're two separate copies. And so we can keep committing them all day. But you know what? Let's say for some reason or not, we actually were pretty happy with the code changes that we did in Code Experiment, and we want to bring them back to our main copy. We don't want to have to try and manually copy all the files ourselves. So we can say git merge experiment, and now it brings that copy of the code and brings whatever changes we made into that code into our main branch and pulls them all together. If you did change the same piece of code in both copies, it's going to give you a little warning and you're going to be able to fix it. It's just going to blend these two copies together and make them one copy. And so take a look at this site. It's called pkyle.github.io learn git branching. This is huge. I would say if you get up to level 8, that is 90% of what you need to know about Git, and it's probably gives you more knowledge about Git than 50% of developers out there, and you'll be putting yourself in a great spot. Another great resource that you can use just to get started is on Code School. It's called Try Git, and it walks you through the steps, just like we did today, of creating a Git repository. And it gives some great explanations on what each command does. So go ahead, try it out. Guys, really try, I know we're really pushing you hard, but keep going on it. This is the type of stuff that you really have to know later on, and so keep working hard. We're almost to the end. Cheers. Talk to you guys later.